Welcome back to Mwendambira Academy, home of mathematics, biology, and chemistry. Today we are going to have a revision. As you know that we are preparing for the November 2026 upcoming exams, and we are going to have a revision on mathematics. So I have just extracted a question on traveled graphs, and I hope you learn a lot from this example of some of the questions which may be asked or you may found in your exams. Right. So the question is here, and we are seeing a diagram. Okay. So this is a velocity time graph. The vertical axis is showing the velocity or the speed of an object moving, and against the time taken in seconds. So there is a statement, as we know that it's very, very important and very encouraged to read all the instructions or the statements on each and every question, so that you won't make mistakes, so that you understand the question as it is. Then the rest will be okay. So it's saying the diagram is the velocity time graph of the motion of an object, given that the total distance traveled is 1.5 kilometers. Find on part A the deceleration during the first 10 seconds. So here we have 0 seconds and 0 meters per second as our velocity or speed. Then we have 15 and 20. This is our velocity or speed of that object moving. Then for the this axis we have got 10 seconds, 20 seconds, and 30 seconds. Then to answer the first part for the deceleration during the first 10 seconds. So we say solution. Okay, on part A, the deceleration, to calculate deceleration is like acceleration. Then we say the final velocity minus the initial velocity. So the final velocity here, from this point to this point, final velocity is 15 meters per second minus the initial velocity is 20 meters per second. Meters per second over the final time reached is 10 seconds, but the initial time is 0 seconds. So we are saying final time 10 seconds minus 0 seconds, like this. So acceleration is 15 minus 20, we get negative 5 over 10 minus 0, we get 10 meters per square second. These are the units for acceleration, right? So acceleration is, here we cancel 5 into 5, 1 into 10, 2. So we get 1 over 2 meters per square second. Right. Because it's deceleration, we are asked to find deceleration. So deceleration is the negative value of acceleration. Therefore, deceleration is equal to acceleration without negative. So it's 1 over 2 meters per square second. So that's it on the first part of the question. Right. Then we move on to part B. So we have to be very careful to maintain accuracy whenever you make a calculation, so that you won't lose marks. Right. We are asked to find the value of t, for which we are given this information that the total distance traveled is 1.5 kilometers. Right. But the distance we are given is in kilometers, so we have to change it to meters. So 1,5 kilometers is equivalent to, when we are given kilometers to meters, we just multiply by 1000. So it's 1,5 multiplied by 1000. Then the units will be meters. So this gives us 150, okay, meters. It's 1500 meters. So to find the value of t, the first thing to consider is that when we are given a velocity time graph, the formula or the idea to find the total distance is to find the area under the curve or on the graph, the area bounded by the graph, right? So what are we saying? We have got a triangle here. Let me label this one A. We have got this triangle, and we also have this trapezium. Let me name it B. So if we combine the area of this part A and B, we get the total distance, but we will get it in terms of t. Then we equate to this total distance given in numerical value. So to find the area on part A or region at A, we say distance is the area of triangle is half base times perpendicular height. Half base times perpendicular height. So our base is this 10. We get it from the axis of time. So it's 10 multiplied by the perpendicular height from 15 to 20. There are 5 units. So 20 minus 5, that's the length from this point. So that's 5. So if we work very well, we get 25 meters. But this distance is in meters because the velocity is given in meters per second. So the distance is 25. But that's not the total distance. Right. Then we now find the distance on region B. So this is on part A. Then for distance on region B, this is a trapezium. So you have to identify the shape, right? Then use appropriate formula to calculate the area under the graph. So for the trapezium, we say half the sum of the parallel sides, these parallel sides, A plus B multiplied by the perpendicular height, the distance in between the parallel lines, which is h. Then right, we now want to substitute. So we say half multiplied by, right, the length of these parallel lines from 0 to 3t is 3t. So 3t plus from this point to this point is 2t. So we say 2t. Alright. Then we now say 1 over 2 multiplied by, okay, for the perpendicular height, the distance from this point to this point, it's given on the vertical axis, it's 15. So multiplied by 15. So we now simplify 3t plus 2t, it's 5t. 5t, then we have got 15 here. Then in terms of t, it will be 5 times 15. Can calculate here. 15 times 5t. Okay, so it's 75. So 75 over 2. So it's 75t over 2. So this value we got it in terms of t. So it means the total distance now, we are saying the distance at region A plus the distance at region B. So the total distance distance covered on region A plus distance covered on region B. So we now substitute the total distance in meters. We got it as 1,500. So 1,500 is equivalent to, at A we got 25 meters. Then plus at B, it's here 75 T over 2. Right. Then okay, we now collect the like terms because this is now a linear equation. So 1,500 minus 25 is equal to 75T over 2. Then if we find the difference on that, 1,500 minus 25, we get 1,475 is equal to 75T over 2. Then we cross multiply both sides by 2. So 1,475 multiplied by 2, we get 2,950. Okay, is equal to 75T. Then we divide both sides by 75. By 75. Then this will cancel. For this, say 2,950 divided by 75. We get 39. Okay, let me leave it as a fraction. It's 118 over 3. So that's the value of T. This one is now the answer for this part. Then in part C, we are supposed to find the average velocity for the whole journey. So the average velocity or the average speed for the whole journey is given by the total distance. Average velocity is given by total distance over total time taken. So since we have the total distance covered, okay, just substitute. So it's 1,500 meters over the total time. We get it from this axis, but it's in terms of T, so we just substitute this value of T. So it's 3 by this value, 118 over 3. So this 3 and this 3 will cancel. So it will give us 1,500 over 118. This is meters per second. So right, that was the question, and I hope you find it very well and it will be helpful, since these travel graphs questions are most common questions in ZIMSEC. So I hope you benefit a lot from this. And don't forget to subscribe, like, and comment, and tell us the questions you need some help from me, so that in the next videos you will see helpful examples of questions which may be asked by the ZIMSEC. Thank you.